Hey everyone! In this video, we are going to be looking at torque directions. And in particular, we're going to be rethinking the right-hand thumb rule. So I have two examples up here, and there won't be any calculations in this video. We are simply going to look at trying to figure out how to decide the direction of a torque vector. So I've got my first wrench up there, my very well-drawn wrench, and it's wrench A. And typically we use what's called the right-hand thumb rule to determine which way a torque vector goes. So it either goes away from us or towards us. In situation A, the little circle with a dot in it, that represents a vector that is coming towards us. It's actually what an arrow would look like if it's coming straight at your eyeballs. In situation B, that circle with an X in it represents a vector that is going away from you. And what you're really seeing is the back of an arrow. That's the little feather fletching on the back of an arrow as it flies away from you. So that's how you remember the two symbols. Circle with a dot, that arrow flying towards your face. Circle with an X, you're seeing the feathers of the arrow flying away from you. Now the right-hand rule, here's my right-hand rule, and I got the camera all turned so my right-hand rule looks correctly, and this is my right hand. You take your fingers and you put them in the movement in the direction that the object is about to be pushed. So in situation A, that wrench is about to be pushed counterclockwise. Because it's going counterclockwise, so my fingers are going counterclockwise, you'll notice that my thumb points towards my face, just like the arrow. So just like that arrow vector is the circle with the dot in it, arrow coming towards my face, that's the direction that my thumb points if my fingers try and go in the direction that the wrench is about to be placed. When we look at situation B, the wrench is being pushed down, which means the wrench, I'll turn my arm around here, the wrench is going to go down this way. See, my fingers are now pointing down to go in the direction the wrench is about to be pushed, and my thumb, don't put your nose on the screen, don't put your nose on the screen, my thumb is now pointing at you. And that's because the vector is going away from me. That's that circle with an X in it. One of the things I want to tell you about rethinking the right-hand thumb rule, maybe this works for you. It's one of the ways that I remember this. If something is going counterclockwise, you are loosening something. You are undoing something. And the way I remembered it, if you're going counterclockwise, it's like undoing a clock. You're undoing time. Well, not really, but you're trying to. If I turn a lid counterclockwise, if I turn a wrench counterclockwise, I am undoing something and pulling that object towards me. If you turn a lid counterclockwise, it will pull the lid towards you, a vector towards you. The lid comes off. If I turn a wrench counterclockwise, the nut will come towards me. It will come off. That is a vector towards me. If, on the other hand, I turn an object clockwise in the direction that it's supposed to go, that will tighten it. If you turn a lid clockwise, you're tightening it. If you turn a wrench clockwise, you are tightening it. And the way I remember is that if I turn something counterclockwise, I'm undoing the clock. I'm undoing time, so I'm undoing the lid, I'm undoing the nut, you're undoing something. If you're undoing a nut, it comes towards you. That's why the vector points towards you. If you are tightening a lid, if you are tightening a nut, you're pushing it away towards you, you're screwing it in. That's why the vector goes away. So if you can use the right-hand thumb rule and go counterclockwise, you'll notice that the thumb always points at your nose. If you turn your hand around so that you're turning something clockwise, you'll notice that your thumb points away. That's the away vector. But there's two ways to remember this. You can remember it either using the right-hand thumb rule, or if you've got a test, or you've got an assignment, or you're just trying to wow someone into going to semi-formal dance with you based on your knowledge of torque directions, you could know that if it's going counterclockwise, that vector is towards you, and if it's going clockwise, that vector is going away from you, and maybe that'll skip all your little right hand flipping around. Thanks for watching. I hope this was helpful, and I'll be looking forward to seeing you next time.